This video is going to take a look at polygons. Shapes are generally the first encounter we all have with geometry. We learn circles, squares, triangles, etc. at a very young age. In this chapter, we will review the name of basic two-dimensional shapes and look a little deeper at their application in the real world. A polygon is a closed two-dimensional shape determined by 3 or more straight lines. The lines are called the sides of the polygon. Where the lines meet is referred to as the vertex. So this isn't any different than what we were talking about before, where rays meet at a vertex. So these these are line segments here because they have a beginning and an end, and where they touch, what they have in common would be our vertex. So any polygon should be, just think back to your preschool days of shapes that you learned: triangles, squares, rectangles, trapezoids, etc. But what's missing here is circles. I do know that I haven't talked about it, but that's because a circle isn't really made of a straight line, right? So if it's not made of a straight line, we're not going to talk about it as a polygon. We'll come back to it in a separate video, and we will talk separately about circles, but don't expect circles in this one. All right, so let's talk about some common names of polygons, and notice it's a little different than what you expect. 3 sides is a triangle. 4 sides I call quadrilateral. Generally, I think if you say 4 sides, like in your head, you think square or rectangle. But because 4 sides can have different shapes to it, including a rectangle, square, a trapezoid, or parallelogram, just generally 4 sides we call quadrilateral. I will talk about that much deeper later, but for now we just want to say 4 sides is a quadrilateral. 5 sides is a pentagon, 6 sides is a hexagon, 7 sides is a heptagon, 8 sides is an octagon, 9 sides is a nonagon, and 10 sides is a decagon. So questions that are popping in your head right now are probably, oh my goodness, does she expect me to memorize all of this? The answer is not really. I expect you to know what a triangle is. I expect you to know rectangle versus square versus parallelogram. Like that'll all come. Hopefully pentagon should be a familiar word to you, so I want you to think 5 sides, but I'm not going to quiz you on what's a nonagon. I want you to see these terms so I can talk about it in this chapter, but I will make sure you definitely know what I'm talking about anytime I ask you a question on the homework or on a test. All right. So not only do we want to talk about the number of sides for a polygon, we would like to talk about the number of degrees it has. Instead of memorizing how many degrees are in each polygon, though, because that can be hard. It's hard enough to remember all the names, let alone how many degrees it has. I want to step you through how would we figure it out? Like, what if I needed to know and I just couldn't remember it? Could I figure it out? So here's what I can do is teach you everything in relationship to a triangle. So as long as we know a triangle of any shape or size has 180 degrees, we'll be able to use this information to find the number of degrees in common polygons from our previous chart. So here's our strategy. To find the number of degrees in a polygon, we need to see how many triangles are in the polygon. It's important that all of the triangles are drawn from a specified vertex and are found by drawing straight lines to the other vertices in the polygon. Now that may not make sense, but it's going to, because let's draw a picture. So I just picked a basic quadrilateral, and this one looks like a parallelogram. That's fine. It could have been a square, rectangle, wouldn't matter. But what I need to do is just pick a point and then draw to the other vertices. So here's what I did is I picked this point and I drew a cross. This point's already connected to that vertex. This point's connected to this vertex. So the only one it wasn't was here. And what that did is it created 1, 2 triangles. Okay. So if I know that each triangle has 180 degrees and I have 2 of them, you can see I did this calculation. 2 times 180 is 360 degrees. So that means any quadrilateral I can think of, regardless of shape, will have 360 degrees. So let's try that again. Let's go to a pentagon. A pentagon has 5 sides, and what we want to do with the pentagon is figure out how many triangles is that. So once again, I have to pick a starting point. So I picked this point, and then I drew lines to the other vertices it's not already touching. You can see from the figure that this creates 3 triangles. So 1, 2, 3. So we need to just say, what is 3 times 180, which is 540. So now I know a pentagon will always have 540 degrees. And I hope you are noticing you're not having to memorize a pentagon has 540 degrees. You're going, I can create triangles. So I'm going to give you another one. I'm going to make it have 6 sides now, and I want you to try the same thing. Okay, so here's a hexagon. Pick a point, draw your triangles, and then multiply how many triangles you get by 180 and figure out how many degrees are in a hexagon. All right, so hopefully you're doing that, or you paused the video so you can do it. So now let's see how you did. And you probably drew better than I did. So here's the point I picked, and then the lines I drew. Okay, so that shows me I have 1, 2, 3, 4 triangles in this hexagon. So this says I need to do 4 times 180, which is 720 degrees. So let's do like a little summary of what we found. Okay, we did the triangle, the quadrilateral, pentagon, and hexagon. I'm throwing the heptagon in, we'll get there. Here are the number of sides it has. Okay, now let's put in number of triangles and total degrees. Well, the triangle is easy. It had 3 sides, that's 1 triangle, that's 180 degrees. Our quadrilateral, when we split it, gave us 2 triangles, so 2 times 180 was 360. The pentagon, when we split it, came out to be 3, so 3 times 180 is 540. The hexagon, which is the one I had you do on your own, gave us 4 triangles, which was 720. So I want you to start seeing that every time I added a side, right? So I went from 3 to 4, I added a triangle. From 4 to 5, 1 more side, 1 more triangle. From 5 to 6, 1 more side, so 1 more triangle. So I'm expecting to go from 6 to 7, instead of 4 triangles, to get 5, and have 5 times 180 is 900 degrees. Something else is happening though too. I want you to notice the number of triangles is 2 less than the number of sides. So 3 sides, 1 triangle. 4 sides, 2 triangles. 5, 3, 6, 4, 7, 5. So it was always 2 less. So this gives me like a generic formula so that I could do as big as I wanted. If I know the number of sides, I can say subtract 2 and then multiply by 180. So let's try this for the heptagon. So, oh, well, we already did the heptagon. I did 7. 7 minus 2 is 5. 5 times 180 was 900. All right, so here's our formula for the number of degrees in a polygon. Polygon with n sides has n minus 2 times 180. So let's look at octagon, nonagon, decagon. This time I'm not going to draw all the little triangles. I'm just going to subtract 2 multiplied by 180. So for the 8, subtract 2 is 6. 6 times 180 is 1080 degrees. Here's 9. That's a nonagon. I subtract 2, 7. I multiply by 180. I get 1260. Here's decagon, 10. Subtract 2, give me 8. 8 times 180 was 1440 degrees. Okay. Just to wrap up our polygon part, let's talk about regular polygons versus just a polygon. So a regular polygon are really the ones we like, where all the sides are the same shape. They're very just pleasing to the eye. So that's something like a square. Do you see how all the sides are the same and all the corners are the same? So that would be considered a regular polygon because all the sides have the same length. Same thing here with this pentagon. All the sides have the same length. Here on the triangle, later we'll talk about this being an equilateral triangle, so a special type of triangle where all the sides are the same. So anytime they say the word regular, it means the sides have the same length. Similar polygons will also come up, which those are polygons with the same shape but different sizes. For polygons to be similar, corresponding angles have to be equal and corresponding sides have to have a constant proportion. So it's not that the side lengths are the same. That's definitely not true. You can see this ABC is much smaller than DEF, but the angle would be the same. So if they say this one was 20, which is not, this would be 20. If this was 70, this would be 70. So they will be the same. I have a whole other video just on similarity that you want to watch because similarity is really important. It's kind of the basis of how we do maps. We take something really big and we shrink it down. We do models so that we can see what a house would look like, right? We just shrink it down. So lots of reasons to do similarity. It helps us to make things in the real world. So make sure you check out that video next.